time since we work on the logs interpreter, and today we're going to continue some work. In the last round, what we did was we tried to implement the garbage collector, but we found that there was some error when we were trying to run the garbage compact function. Basically, the garbage collector is changing the key somehow, and the last we ran it on 25 underscore closure. And we found that for some reason the thing that is pointing to has changed to some random key over here. So let's take a deeper look into how this error appeared. So before we do anything, let's build the let's check. Nothing much. Okay, GDB logs. Okay, 25 closure. Okay, so we receive a seg fault on trying to retrieve this particular object here. And let's take a look at what object that is. To do that, first we do some back tracing. So this particular object here that's being marked right now is one of the objects from a table. Don't know which table. There's very little tables in our whole program, so it should be easy. So mark compiler roots 998 mark table. So let's take a look at what is going on there. Okay. Logs. Take a look at the code here. Compiler C. Right. Compiler search. And this compiler object is basically the current object. Do we have a current object? We do have the current object. Okay, so we try to mark this table search. And in the mark table function, what do we have here? Table.c on 193.139. It's trying to mark the entries key, which is a string, and it's not going well. Right. So let's take a look. This is search entries. Unpack it. And the first one, the key, right, is not doing well. Why is that the case? Right. Why is that the case? Okay. Let's do something interesting here. Let's pause at a random. Let me see. Nothing is set, so it should be all zeros, but somehow there's a weird one over here. Let's look at the structure of entries. Alright, let's take a look at the structure of entry. So, that's in table.h. So I have a key, I have a value, and object string. Right. It shouldn't be auto, at least not in that way. So let's take a look at Oh, this is fine except for the first one. Okay, let's do a okay. Let's try to figure out how to is data. Breakpoint. What's the command? No, that's wrong. Okay, is that a help? Okay, let's take a look here. Alias breakpoints. Hey, that's weird. How do I use this? How did I use to trace points? How did I use to trigger that? Watch points, right? Watch. Okay, nice. I want to watch this in particular key. Okay, show all breakpoints, info breakpoints. Okay, very good. Now only have one, and I want to run the test again. Okay. Before that, I don't have anything. Now I've set it, and it's object string, right? Next. Okay, now my continue. I've set it from something. Okay, so I changed a different compiler object. I set it, and now it's changed. Set is marked, right? let's see what's going on here. So somehow this setMarked is messing up my object representation. This is weird. Okay, let's take a look at object.h. setMarked. Maybe the representation here is wrong. I shouldn't have shift by so much. Right, it's marked. Oh, I think it's only a 47. Let's try to figure this out. So from here, it looks like the first, the header, I shift it 48 times, so the 49th one is the, whether it's marked or not, right? So I need to write 1 and shift it 48 9 times. Is that right? Okay, let me see. What is the representation for the header? Okay, let's take a look at this. How many bit is this? One, two, three, four. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. 1, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay, nice. 16. Right. 16. This is the actual object. Next. So my header, what's this? Okay, so there is 12 here. This looks wrong. Let me think. FF. I shift this FF by 48 place. So that is divided by 8, 6 place. Is that correct? That looks wrong. Okay, maybe I got all this wrong. No. 56 onwards. Okay, I need some instruction on what is going on here. Okay, I probably got the header implementation a bit wonky. So okay, let's check right here. Okay, let's work back. What are we trying to implement here? At the is marked. This mark is basically the thing at the 49th place. And here I have 48 bits, right? Okay. Then before that is type. don't know how many bits. Next is basically the last 12 times 4. Okay, this is 8 times 8. 8 times 6. No, 4. 4 times 12. So this is 12 over here. This one is 1 bit. Actually, wait. Okay. This is the first 64 bytes, right? 64. 56. 56. Yes. So the first two is type. Okay, never mind. This is 0 times FF. Okay, then I have 1 byte here for marked. Okay, sure, it's 2. And the left over here is next, right? Trough. Okay. So okay, nice. So it's marked is basically shifting 48 because there's 4 times 12 and getting this portion here, then checking with O1. How to set mark? Okay, check header. Let's try that again. I want to copy. Okay, this one invert, and this one shift. It looks correct. Okay. F. Boo-boo. Why can't I use printf? Wonky. How come I can use printf? No. Memory.c. I need to import probably this. Okay, object.h. Okay, let's forget. Is it? No? not. It's probably this. Object.h. Do you know? Oh, that's not right. Okay, let's see where printf is from. It's in stdio, apparently. Okay. I think I'm just missing stuff. Okay, so printf. What should we print? Let's print a present in x. Okay, I want to use x here. Percent x. And this will be object header. Okay, no, actually we should use a few other things. Okay, I want to see whether it's okay. Object header, whether it's marked or not. Okay, so before we do that, let's check it out. Okay. Do you print anything? Oh, probably did. Let's our stuff. Okay, I want to set all this object. How come the header is so weird? Oh, okay, just shifted. I need to unpack this. AI function pointer. No. I want to show the content of this header, which requires me to do this. Nope. I'll cast. Yes, wrong. Header is equals to. Actually, let's just print again. Just. The first field is the type. First field byte is the type, which may be off by a bit, and the rest is the next pointer, which is okay, I guess. So let's see how many we miss. Right, 1 2 3 4, 1 2 3 4. So the rest all is 0. Okay, let's try to do something different where we set a okay, so total I got I should have 16, right? Here I only have 8, so basically I'm missing half of it. And let me check, maybe I'm printing it wrongly. Format specifies unsigned int. Oh, I want unsigned long. Okay, for unsigned long, we need to use LX. Right now, so I'm missing quite a bit of stuff, which is not the best. Okay, let's try building it again. We have everything now. Yes, we do. Okay, yes, we do. We do have everything now. Those that are missing a few stuff is basically 0, 0 in front. But we only use 16 for 1, 2, 3, 4. So this is basically marked as true. We do see it working well. The question is then, I think it's correct. Okay, I think the question is then, how come it's setting something weird? Means that this must be a header object of some sort. Okay, let's check the position. Okay, before we go any further, let's check the position of, let's view again. Okay, now we go into GDB, we run our test. Segfault is okay. We watch for, okay, we are doing current search dot entries 0. Okay. Okay, let's watch this. And then let's run it again. Yes. Set from something unknown to a 0. Okay, this is just initialization. Continue. Set from 0 to something unknown. This is basically the new compiler. Okay. Initialization of the entries. Okay. This one, right? This is where it gets wonky. Somehow, when I set an object at this location, this value changes. So let's look at the location. Maybe it's doubly used, right? Let's look at this location. This location is exactly the object. Should it be that case? And what is this object? Okay, backtrace. What is this object? So 139. In table, okay, let's close everything. In table.c in 139. Maybe we got our table implementation wrong. Okay, same thing here. This is marking the object as sin. Let me see. I shouldn't be marking the key. Should I? Okay, what does marking object do? Maybe this is wrong. Maybe I shouldn't be marking the key. What should I be marking then? This is a key to the object. What's in it is 0. Before this is 0. That is weird. No, it's I caught this, and now I'm caught to somehow this key points to its own position. That's weird. That's interesting, right? The key points to itself. Okay, so where do we set the key? Right, table. Okay, table. Okay, so okay, where do we set the table? Where do we set the table? And what is that table code doing, right? 139. 139. It's going through every entry. And if the key is set, I will want to change it. But very oddly, the entry.key refer to itself. Okay, so if we print this, now it's showing some weird stuff already. Oh. Okay, so before I mark, let's make it such that I print out marking key. Let's make sure I print it out. What does this give me? I know it's this. Somehow the key is pointing to itself. Okay, no. Let's take a look. What is this object supposed to be? And somehow it's his own self who sets it though. Who sets it? Right. It's very interesting who sets it. Okay. Let's confirm this. Right. Build. Let's run it in GDB, right? Daily run. I received some error. I'm marking some weird key, some really weird key. Okay, this is supposed to be a string. So if I do a object string on this address, it will basically give me something that is correct, reasonable, right? If I do something like this, then it's gonna say, hey, still reasonable. But when I do it on this wonky address, it's gonna give me something weird. Maybe, I don't know. It looks like it's giving me something weird because it's casting something that is not as a key. And when I do this, oh, actually, no, actually, maybe I have got something. It's 5 characters throw. Okay, so maybe I've got something. Could it be I release it, but somehow I still use it? Marking the key. To mark this key, somebody first has to set it, right? Okay. Let's do something a bit different and actually print out what the words are. Okay, this is a bit weird, but I'll do it like this. Entry, cause I know it's not empty. Got char, right? Let's do it. Okay, run test 25 closure. Yada. 700 always has nothing. Oh, it's clock. It's clocked, it's used. And somehow I am not respecting that. Okay, so now we realize something that's wonky with our system here, right? Well, what is it? So we realize that. Okay, so what's today's date? 609. Then after that, we had it gone missing. Then after that, we have it go. Yeah. The object string for the word clock is not marked as used, and therefore it is stolen. Okay, let's take a pause here for now. Now that we have figured out what's happening here, so what are some things that we can possibly look into later on, right? So now that we know that the memory itself is stolen, because when I do current search entries, we know that it later got stolen by this, right? It somehow got stolen and used as current.search.entries. So we need to check our memory, right? How is it located? How come it's there when it's being used? Are we marking the words correctly? Okay, it looks like we are marking the words correctly. Looks like we are, but are we allocating memory that is being used? Okay, that's all for now. We'll try again in the next